Okay, this really cool problem is asking us to find a vertical line that divides a region bounded by these three curves, well, one curvy thing and two lines, into two equal parts. So to do this, let's first figure out what this region looks like. So as opposed to using x equals radical y, that's kind of goofy. So I'm going to instead write this as x squared equals y. So I recognize I'm really just talking about a parabola here, right? So y equals x squared looks like this. X equals 2 would look like this, and y equals 0 would look like this. So the region in question is this region bounded by the blue and the red and the orange. Okay, so first, if we want to cut this into two equal parts, let's first figure out what is the region's area altogether. Okay, and to do that, let's do an integral. Let's do an integral. What color should I use here? I guess green. Integral from 0 to 2 of x squared dx, which would be equal to the antiderivative of x squared is x cubed over 3, bounded between 2 and 0. And of course that would be, let's see, we evaluate at 2. 2 cubed is 8, so this would be 8/3. And when we evaluate it at 0, we end up getting 0. I don't know what's going on with the pen right now, man. Oy. So 8/3. Okay, so if the region between, or the region that's bounded by these two lines in this curve is 8/3, and we want to cut it into two equal parts, that means we need to make our equal parts not 8/3, but what's half of 8/3? But 4/3. And we don't technically know where this line is going to show up, so let's label it like right here and call that K, because that's really where we want it. So we want to make sure that this region over here is 4/3 and that this region over here is also 4/3, because that's what it would mean to cut it up into two equal pieces. So what kind of integral would we have to perform to figure out what makes this equal to 4/3? Well, of course, that would be an integral from 0 to k, because you don't know what k is. We're going to find out what that is. X squared dx. We already did the antiderivative of this, so fortunately that's x cubed over 3 evaluated from k to 0. Notice I chose the k and the 0 because this makes it nice and easy to evaluate as k cubed over 3 minus 0, because the bottom bound is 0. And what did you want this to be equal to? Oh yeah, we wanted it to be equal to 4/3. So notice now you have an equation you can solve. K cubed over 3 equals 4/3. Multiply both sides by 3 to cancel out the 3's. When does k cubed equal 4? Well, that occurs when k equals cube root of 4. Okay, so not the prettiest number in the world, but that is the bound that will allow us to cut the region under x equals radical y, x equals 2, and y equals 0 into two equal pieces. It would be a vertical line that goes through x equals the cube root of 4.